us work out this question here under projectile motion. This is Mr. Skazwe. Let's answer a question here. Previous tutor here. A particle is projected from the ground level with an initial velocity or speed of 20 meters per second at an angle of 30 degrees to the horizontal. So this is a demonstration of the motion which I have drawn here. So they're telling us to resolve the initial velocity into horizontal and vertical component. Know that the horizontal is the x-axis, which is just u cos theta, all right, and use 20 to be cos 30 degrees, and this will give us 17.32 meters per second. Just like that, you are done. Okay, then in the y, okay, in the y we are saying, which is the vertical, okay, so it is u sine theta, so the y deals with the sine theta. I'm getting 10 meters per second. That's all. So part A is done, just like that. Okay, then also let us look at B. B says determine the time taken to reach the maximum height, meaning the time it will take for this friend of ours to come then reach at this particular height there. So one thing that we need to understand, that we can use any formula. We can also use this. Okay, you know this equation, the one that you say this, but because this friend of ours is going up like that, so it's going against gravity, that's why we're having negative there. G is negative. Now one thing that we need to understand, that once you reach maximum height there, okay, the final velocity here, the final velocity is always 0, okay, at maximum height, so put 0 there. Okay, then we have initial is what, 20, sorry, in the y, uy is 10 minus 9.8 then times t, so we get negative 10 is equal to negative 9.8 t. Of course, just divide throughout by 9.8 because both of them are negative. I'm getting 1.02 seconds. C says what? Calculate the maximum height attained. So maximum height is given by, do you remember the formula? Over 2g. Now we are talking about the initial velocity in the y. In the y it is 10. Then we square it. Specifically, then we put 2, 9.8. Do you know why we are using y? Because this is height in the y. Then let's punch everything together. So I'm getting 5.10 meters. D, determine the total time of flight. Okay, so for total time of flight, meaning we need to look at the distance, at the time taken from there and also from there. But we know that from here to here, it was 1.02 seconds. All right, meaning if it has to be again from there to there, we just double it. Okay, that's the easiest way we can do it. So time of flight, time of flight will be equal to 2t, 1.02, and this will give us 2.04 seconds. Then let's look at E. E says find the horizontal range. Now for the horizontal range is just velocity in the x times time. Let me take you back. What is velocity? Velocity is displacement over time, right? Displacement over time, that is velocity. So if I need to find x, which is displacement, it's just v times t. But this displacement, okay, this displacement is what we're calling range. And this velocity, it will be velocity in the horizontal, then time. Exactly here. So you need to specify the type of velocity that you are using. It is horizontal. This is a range here. I showed you here. This is a range. So the horizontal velocity is 17.3. So we get 17.32. We multiply by the time. Which time are we going to use? The time taken or the time to reach the maximum height? Since the range is from here to here, we are going to take the time of flight, which is 2.04 seconds. And of course, our range will be 35.3 meters. And just like that, you are done. Don't forget to subscribe and leave a follow.